Hey guys, I hope you are doing great and welcome to this YouTube channel. In today's video we are going to, which is the next one of our playlist, okay, we are going to work on the storage engine layer, right? As we just said briefly in the previous video, okay, at the end of the previous video, our in-memory cache server is going to have three layers, right? Firstly, we are going to have the network layer, then the protocol layer, and finally the storage engine layer. Each of these layers communicating between each other, right? But we start by the storage engine layer because it's the brain of our system, right? It's the guy which is going to be responsible to handle almost the basic logic, right? So how we are going to store, retrieve, and get information, the data structure we are going to use, and how we are going to protect this resource in memory. Okay. So before diving into it, we have to highlight three specific points, right? Firstly, along the way, we have to make sure that our system is stress safe. What do we mean by that? Because we are going to handle thousands of concurrent read and write operations at the same time, okay, we want to make sure that two threads, right, doesn't have the possibility to update the state of an object in memory at the same time. Okay, that's why we are going to use what we call in Go a mutex, okay, which is a way to protect a resource in memory, okay, and prevent many threads to as I just said, update is a value, okay, of an element in memory at the same time. Okay, to give a little bit of context about that, let's suppose that it's the object in memory that we want to manipulate, right? And the first thread comes in, okay? Instead of just directly start to manipulate the resource, right? It's going to take a lock and lock that resource, okay, to prevent other concurrent threads to have access to that resource, okay. We have two possibilities. We can lock in read, or we can lock in write, okay, and we can lock in read and write. Okay, so let's say this thread 1 comes in, okay, he take a lock, okay, that means no one thread can have access to that resource in memory, okay. The second thread comes in, okay, because the first thread has already got the lock, right, he cannot work with that resource, right. Instead, it's going to wait until the first thread release the lock and unlock that resource, right. Then he can take the lock, do what it has to do, and release the lock. Okay, that's how we manage the thread safety of our system, and we prevent us from having a lot of data inconsistency. Okay, next we want to make sure of the latency. Why we need our system to have a very low latency, okay, by making sure that almost all of our operation happen in a time complexity of 0.1 on average, right. And to do so, we are going to use a hash table, which is the right data structure in that case, because almost all of the operation on hash table are 0.1 complexity, right, because we know exactly the memory location of the memory location that we want to manipulate. Either either we want to add an element, remove an element, and delete an element, right. In Go, these three operations, right, have happened in a time complexity of 0.1, right. That's what brings us through that data structure, right, which is called a map in Go. Okay, and now talking about the overall data structure to store data, right. Instead of having one big object, okay, one big map where we are going to store different key and value, okay, we are going to have, we are going to split inside many little objects, right. So instead of having one shard, okay, we are going to have an array of shards, okay. And because we want to keep the latency very low, okay, and you don't want to increase the complexity to ON because now it's an array, okay, you're going to use a hash function, okay, because almost every operation are going to send a key Okay, based on that key we can have a unique number. Okay, so that key, after passing by through our hash function, is going to return a number. Okay, and this number is going to be like the position of the exact shard that we have to forward that request to. Okay, so that's a way for us to improve the to reduce the latency of our system, right? And to prevent us from having a bottleneck, because we have 1,000 of concurrent threads, okay, blocking inside a queue and waiting for a lock to update the state of an object in memory. Okay, that's what lead us to that choice. Okay, so that's a little bit about all the things that I want to highlight before we dive into the coding part, right? So next we are going to move on to the coding part itself, right? So let's get into it.
Okay, now we have an empty project directory. Okay, it's empty now. It just has a go.mode file, which is going to get the track of the dependency that we are going to use, right? And the next step for us is to set the basic folder structure for our project, right? So we are going to use the command structure, okay, where we have we're going to have the cmd folder. Okay, it's going to be like the different entry point of our system, right? So inside the cmd we're going to have, because the first entry point is going to be through CLI, right? So we're going to have a CLI folder inside. Okay, and now we are going to have an internal folder. Okay, it's going to be for the internal feature, for the core feature of our system, right? And the first, because you start building the storage engine, right? So we're going to have inside the internal the storage folder. Okay, it's going to be where we're going to have all of the feature related to our storage engine, right? So it's going to be for the storage engine feature itself, right? So now that we have this set up, okay, we can start, right? But before I want to define a Makefile. Okay, so our Makefile is going to have all the commands that you are going to need, right, to execute our code, right? So let's say when we are on the all commands, we're going to have a build command, right? A test command first, right? A test command, right? And this command is going to run the command go test. Okay, then you are going to have the build command, right? The build command. This command is going to run the code go build. It's going to create a binary folder where it's going to store the build file, right? And the name. So instead of putting the raw name, let's use a variable, right? Binary name. Okay, and main.go, right? Main.go. No, I guess it's better this way, right? So we are going to declare the variable binary name here, which is going to be MemoryDB. So it's going to create a file called memory.db, right? That an executable called memory.db when you're going to run the build commands. Okay. What else? So we need to have if you run the run command, it's going first to run the build command, then it's going to execute our executable file. So this run command is going to depend to the build command, then it's going to execute, it's going to execute our executable, right, which contain the build of our project, right? And we need to also, because when you are going to run the go build command, it's going to create a binary file. We also need to have a clean command. Okay, the clean command is just going to remove that binary file because it's a folder. We have to use that error for the recursivity /bin, right? And it's going to also call the go clean command to clean the cache, right? And yeah, so let's now use the funny. That's just all the things that we are going to put next to funnies, because we want to tell it to not, when you are going to run that command, right, like go test, not looking for a file, but knowing that it's a command itself, not a file, right? So that's why after that, all the commands, the possible commands, right, we add that next to that funny, right? So build, run, and clean. Okay, so let's run the make text command. Go text, okay, running, okay, no package, okay, no package to test. Okay, that's perfect, right? So that's going to prevent us for every time to run test having to run this write this go test commands, right? It's going to be very exhaustive, right? Okay, now let's get into it. Okay, so let's follow the test driven development approach, right? So we start by writing the test, and the test leads us to the exact amount of code that we have to write, right? So the test is going to guide us to not having to write unnecessary code, right? We just have to write the exact amount of code that we need, right? So the first thing that you're going to do is to create a test file, db, okay, let's call it the database, okay, db-test.go. okay, it's inside the package. I don't know why I always have this problem to write package first. Okay, the first is going to be to test if we can store and get data, right? Yes, we can store and get data. Okay, and okay, to do so we're going to have a function test can store and retrieve data. So inside the same test, right, we are going to test. We can I don't want to have two tests for that, right? I prefer to have just one test, right? So before do anything else, what do we need first, right? We need to have our way of, so our database setup, right, which is an array of map, right? So we need to have our data structure set up already, okay, which is going to be an array of map, right? And each map is going to have let's say index. Okay, that's what we talk in the first part, right? To prevent concurrent threads to having access to the same resource at the same time. Okay, and we're going to have what else, a map itself, which is going to be a map of string and and array of byte, because instead of having to store a raw string, right, it will be better if we store an array of byte directly, because it's going to prevent us to remove this extra passing from byte to string, right? It's not really important for us to store a string where we can store raw bytes, right? And I'm questioning myself if it's not going to be better to also store as a key an array of byte directly. No, we're going to get in trouble to retrieve information. Okay, I've never done that before, like storing as a key an array of byte. I'm going to test that later, but not in that video, right? Okay, so we need to have this data structure set up, right? And as we just said, this array of map is going to have a value, right? It's going to be, it could be an array of just 8 short, right, or 1000, or the number that we want. So it brings me to think that it would be better if you have a function, right, that we are going to call to initialize our database, right, like creating the array of shard based on the size that we are going to define, right? Yeah, so that means here we are going to call, we need to have a function that we could call something like new shard map, right? New shard map. We are going to pass the size of the map, right? Let's say 8. Okay, shade map, new shard map. Yeah, the function doesn't exist yet, that's why we got this error message, right? Now once we have our shard map, right, we need it to have some property, right? We need to be able to you need to have a get method, right, and also a set method, right? So we need to be able to do something like our shard map dot set, okay, a specific key, right, and a value, right, and we need to retrieve that. We need to be able to retrieve that, right? So we also need to be able to do a sender get, right, a specific key, and expect to have a value, right? So let's create this. Okay, let's have a variable that we're going to call key, which is going to be, let's say, name. Okay, okay, let's say name, string. Okay, and let's say we have a value of type an array of bytes, right? And let's say we get something like that, subject. Okay, so because we are not going to store a string, okay, we have to cast it into an array of bytes, right? Okay, now we are going to call the set method, and we're going to call the get method, right? So we have, because the get and the get could return name if it doesn't find what we are looking for. So inside the test, we are going to make sure that we have retrieved something, right? So let's say the gut is going to be equal to what we are going to receive, and we want to make sure that what we receive is exactly what we saved, right? So to check it, we are going to compare the number of bytes. I think it's byte that equal something like that, right? Yes, it's to compare two array of bytes, okay, to check if they are the same, right? So we are going to check what you have received from our database and the expected value, right? So if the value that we receive is not the one we have set already, okay, we are going to return an error, right? An error message, right? Like received incorrect value from the DB, okay, expected but got, okay, string. What we expected to have this, right? But we got this, unfortunately, right? So if you are running our test now, it's going to fail because there is no function sharp map, right? So the thing and the place where we are going to have that, right, is here inside our db.go, okay, the guy which is going to contain the logic, right? So it's the package storage, okay, and we are going to first define our structure, right, before having this. No, let's say we have this function, right, new short map, okay, okay, we are going to have the size, okay, it's always going to be positive, right, and just ends, right, the size, okay, and it's going to return an element of type, let's say engine, right? Okay, now we have two problems. The first is he didn't understand what we mean by instead of following engine, use shape map. Okay, it's going to return a pointer to our structure, right? The point is we have two problems. First, the structure is not defined, right? Next, the size is not used, right? And this function doesn't return the thing, right? So let's start by creating our structure first. So we are going to have a shard map, okay. It's going to have an array of shards, okay, shards, right? Each shard is going to be, shard 2, which is going to be a structure, and the shard is going to have a mix, as we said, right? A read write me text, right? It's coming from the sync package, right? It write me text, okay, and it's also going to have a map, okay. The data is going to be a map, string, and an array of byte, right? And okay, for the size, the thing is we are going to we have first to create a structure, create a shard map, right, and loop, okay, and initialize each shard, okay, and initialize each shard, right? So the shard map itself is going to be shard map, okay. The shard is going to be make an array of shards, right, and the size that we have already defined, right? But what we got here is that this SM has not been used, right? That's true. And undefined size, yeah, we have done this mistake, right? So, and now the thing that we are going to return is, recognize this SM, okay, but it doesn't say anything, but we have not yet looped all over our shards, right, to initialize each map, right? So we are going to do a loop, right, range of the single chart, okay, and for each one we're going to assign chart y, which is going to be equal to the data is going to be equal to, we're going to make a map, right, string and byte. That's perfect, right? Now your short map, okay, it's not okay. It's not looking for the set method and the get method, right? Because you have not yet defined it. Okay, so we are going to write this method, right? So we are going to have a set method, okay. It's going to take a key of type string, and the value is going to be an array of byte, right? And it's going to return nothing. We don't need it to return anything, okay. We're also going to have a get, which is going to take a key of a string and return an array of byte, right? Okay, it's looking for, okay, there's nothing returning now, that's why it's crying. Okay, so the thing is, once we have the key, we need to know exactly where we are going to, in which shard we are going to store that value, right? That's why we need to know exactly the shard where we are going to store the value, right? And to know that, to know this shard, right, you have to do it based on the key, because as we said in the intro, we're going to have a nash function, right, which is going to take a key and return a specific number, right? So we're going to have a private method which is going to call get shard. It's going to take the key, right? And once we are going to receive that, we are going to call the mix method of our shard, right? And because we have to write to it, we are going to lock it first, right? Then always make sure that we are going to release the lock, even though something won't happen, right? Read unlock. Okay, and finally we are going to that chart, right, at a specific key, right, put this value. Okay, the problem is that the get chart method doesn't exist yet, right? We are going to create one. Okay, it's going to take a key, a string, and it's supposed to return in pointer to a chart itself, right? So the thing is, you need to know exactly. Okay, we need to call. Let's say we have to do with you're going to have this hash function first. Okay, this hash function. Okay, it's going to return something. It's going to return a key. Okay, and based on the key that's going to return, right, or let's say an index, okay, we are going to know exactly in which shard we are going to in which shard you're talking about, right? So how we are going to do that? So let's say we're not going to write this code here. We're going to have an hash key. Our hash key is going to be equal to we need a method that we are going to call so we are going to have we are going to call a hash test method, right? The thing is, let's explain it. This method is going to return a suite of number, right, within a 32 byte, right? So let's say something like that, right? And we now have to make sure that, because for the same key it's always return the same number, okay? And we have now to make sure that this number returns something within a range of the number of shards that we have, right? So let's say if you have 8 shards, right, we want this number to return something between 1 and 8, right? And the magic is no matter how big the number is, if you do the modulo operation, right, of 10, it's going to return a value between 1 and 10, right? That's how we make sure that first we return something unique, and then we cast it inside the range of shards that we have, right? So now that is going to return a number, whether it's 1, let's say we have 10 shards and you return 4, we know exactly that we are going to send that we are going to do that operation into the 4 chart, right? If it's 1, it return 1. We know that we are going to do that operation to the first chart, right? So that's how we are going to do, right? But I don't want to put the function of this guy here, so that's why we are going to have an util package where we are going to have all this reusable function. Let's put it here first, right? Don't try to be 100% clean, okay? We need some dirtiness sometime to go faster, okay? So we are going to have a function hash32, right? It's going to take a key, string, and it's going to return a number, always going to be positive, right? Into a 32 byte range, right? So there is a package called SNV. okay, the hash, we generate a hash, right? FNV, right? So new, I guess it's new 32, right? And now we are going to write inside it, so you don't have to understand exactly what's happening here, right? If you want to do so, we can go in the documentation and try to read a little bit to, you know, understand what each step does, right? But in the frame of this video, we don't really need that, okay? We just have to do the thing, right? But what it does is just to create a hash, right? So you're going to write the key, okay, to cast that key into an array of bytes, and finally we have to return hash.sum32, okay? So this guy is going to return as a hash key, not hashed key, okay? And we now have to guess the index of the shard based on that, right? So the shard index is going to be, as we just say, if we take that number and we do the modulo operation within the range of the shard that we have, right? The length of, you know, where do are we going to get that share? We made a huge mistake, right? We made a huge mistake because all these functions deserve to that structure, okay? We have first, okay, because this function doesn't belong to that DB, okay? This function belongs to that structure, right? So we have to do that to precise that, okay? This function belongs to this structure, right? Okay, now we can get his property, right? Invalid operation hash key modulo len mismatch type. Yeah, that's because this hash key return an unsigned int 32, right? And the len return an int, so we have to cast it to an unsigned int 32, right? Perfect, right? Now just return that shard, right? Because we now have the key, okay? So just return the address of that shard, sm.shard of that shard index, right? That's perfect now. Okay, now that we have a get shard doesn't belong to that guy. No, get shard doesn't belong to that guy. Okay, get shard, we need to send the size of our shard, and which is going to be an int, okay, and it's going to be of our size, right? So why I did that, I don't want this get shard method to be a method of, you know, a function of the structure, because, you know, it has nothing to do with that function, okay? So it's just a kind of helper which has job to job to help us to get the, you know, a specific shard, right? So we don't have to consider it as a function dedicated to this shard, right? So but now the thing is, how are we going to return that? But no, we can keep it as a function of this shard, but just let it private, right? So that no one externally know that we have this function, right? Because it's just going to be used internally, right? So sm.get shard, okay, Now we have the get method, right? So the same way that for the set method, right, we get the exact shard, we update the value, right? For the get method, we get the shard, okay, we lock it, but not in white and read, but just in read, right? Because we don't want two concurrent threads to have the read access at the same time as us, right? So we're just going to block it in read, right, and retrieve the value. Then yeah, so let's get the shard, get shard, okay, based on the key. Now lock the resource, right, but in read, okay, read lock. If you go, you're going to see that the read lock happened before relationship indicated to the race detector via unlock. Okay, this method below temporarily disable handling of race synchronization, even in order to provide the more precise model above to the race detector. Okay, read lock read. Okay, so it just locked for reading. That's what I was looking for, right? It just looked for reading. So now we lock that. Never forget, so that if something will happen, okay, we always want to unlock it, okay, to not create a bottleneck. Okay, now we are going to return that shard. Okay, the specific key, right, which is an array of byte. Okay, so let's see it again, right? So we have our shard structure. It has semi-text, right? It has an array of shards, right? And we have our shard map, right, which is, you know, the parent data structure which contains the shard, right? Now we have a public new shard method, right, which allows us to this new shard map function allows us to create a shard based on a specific size, right, and you return a pointer to that the pointer of that structure, right? And the shard map has a set method, right, a get method, right? And how a set method works, right? Because we have an array of shard, okay, we need to exactly know in which, you know, shard we are going to go, because that is an array of shard. Well, so we're going to have shard 1, shard 2, right? So we need to know exactly where we are going to go. Okay, that's why we call this get shard method, right, which in fact just use a hash function to return, you know, a unsigned integer to number, right, based on a specific key, right? And we use the modulo operation to make sure that to fit in this number, how big it is, in the range of the shard that we have, right? And we just return that specific shard, right, the address to that shard, right? So after that, we just log that resource to prevent other concurrent threads to have access to that resource, right? And we update a value, okay, of its map, right? The same for the get operation, just that instead of update the value, we just return it, right? Okay, now you know, okay, it doesn't cry anymore. Let's run it to see if it's okay. Okay, so now we get an error. Okay, fatal error sync unlock of unlock read write mutex. Unlock of unlocked read write mutex. Okay, that's like, let's get back to this TB. Okay, where that error happened, inside the GB line 39. Okay, that unlock. Okay, I see. Okay, I see. It's because we have unlock. You have lock in read, right? But now we are trying to unlock, like, because this unlocking in read and write, right? It's a lock in read and write, but we have just lock in read, right? So you don't understand why we are unlocking in write while we have just lock in read. So instead we have to use the read and lock, not the unlock, which unlock in read and write, right? So let's test it again. Perfect. All right, that's perfect, right? Now let's continue, right? It's okay for the first test, right? So now let's test that. Let's test if it's returned nil, right? If no key has been found, right? Return nil. If key not found. Okay. Okay, so same thing, we have the same new short map 8. So instead of having to write it every time, let's create a const here. We're going to go short size, okay, 8. So just use this, just replace this 8 by short size. Not for you, buddy. Right. Okay, so now what we're going to do is you have the key or the value. Okay, we're going to do it again, and we're going to make sure that it has to return nil, right? If it doesn't find anything, right? So we have to get one key, okay, and if the key is different than nil, okay, okay, if the cut is different than nil, right? What are we going to do? What are we going to do? Just write something like key not found, expecting that but get that, right? Expecting nil, but got that, right? Okay. Sorry for the track of a noise, right? Okay, so let's see what's happening. Oh, it works, right? Because by default, if the key in a map, if a key is not found, it's going to return nil. Okay, so yeah, that's true, but just let this test, right? Just let this test, right? Now one last test, retrieve can retrieve elements, right? Testing, let's say. Okay, the same, we have our shard, we set a value. Okay, we are doing this thing almost in every test. Okay, we're going to optimize later. Okay, So now let's call the del method, right? The del method of that key. Okay, now obviously if you call a get method for that key, okay, we have to receive nil, right? So let's write something like value have been removed, expected to get nothing, but get that, right? Okay, it's crying because there is no del method, right? So again, we have to create one. Okay, del method, right? We just pass the key, and I don't really expect it to return something because I don't really expect it to return anything because I want to expect it to return enable, but I don't see where it can break at the point to return enable. I don't. So instead, just call it. Okay, if it has done the job, we're going to check it, right? But if I'm wrong, we're going to improve that later, right? So for the del, what we have to do, right? The only thing that you have to do is just remove that key inside our map, right? So we are going to do the same thing. Okay. Sorry. Okay. We are going to instead of just locking, we have to lock in read and write because we have we want to delete that, right? So we can afford to let someone write inside it, right? That makes that lock, right? And we just call this delete function, okay, dot short data, that specific key, right? No, it's like it's okay, it's this way. Okay, so we just get the short, we lock it in read and write, right? And never forget to unlock, right? And we just call the delete. Okay, I don't think the delete can break, you know, given the delete built-in function delete an element with a specified key. If m is nil or there is no such element, delete is a no-op, right? So there's no need for us to you know, make some kind of checking if an error happen, because it's less likely to, you know, to break something, right? Where's that guy? Yeah, it's there. Okay, so just save it and run the test. Perfect, right? So we have our DB, right? We can add an element, right? We can retrieve an element, right? We can get an element. Okay, we are going to start by just this three basic feature, right? And I also have a concern is I don't really like to see that on every test I have to do the same thing. I feel like I have to, you know, because on every test I do the same. I create a shard, I use the same key, same value, I set the value. So let's, you know, extract it inside the function. Okay, okay, let's call it build system under test. Okay, and this function is going to return a pointer to a short map, right? Because later we use that, right? So okay, sum is going to be build system under test, right? and yeah. Oh, the key, yeah, the key, but we almost use the key everywhere, right? So it's going to be constant, right? The key, centric, okay. So you don't have any reason to cry, bro. Okay, so just return that short map, okay. So we are going to remove this huge, replace this huge big guy by that, right? But the problem is I don't feel like our test tell the intention anymore. Let's get the value, right? We use the value almost everywhere, so what am I doing? So now we have point of Cedric, right? Oh, wow, shift. The syntax. Okay, what's wrong? What's wrong with you? Byte, the value of type byte is not constant. Okay, sorry. Okay, I've never tested before, so I cannot have an array of byte as a constant. Okay, I have to read it later. Okay, value is an array. Okay, like this. Okay, so that's a little bit about the first version of our storage engine, right? So we have shard, you have shard map, right? We have this basic feature, right? So that's all, right? In the next video we are going to now deep dive into the next layer, which is the protocol layer. So I hope you enjoy. I know that this video was pretty long, but I was coding live, right? And so for the experience to be the most, right? And I'm just waiting for the next video. Thank you. So now let's test it, right? We don't have any entry file. No, it's gonna be because it's as our main.go file is going to be inside the CLI.main.go, right? So let's create a main.go file. Okay, the package main. Okay, the fragment. Okay, print line hello world. Okay, now let's run the make build. Okay, we got an error message. Yeah, we made a huge mistake. Okay, it thinks that we are trying to execute this file, right? Because we have forgot to use the dash O for outputs, right? Let's run it again. Okay, now let's run the make run hello world, right? Make run hello world. Now let's run the make clean command. Okay, remove the error. Okay, there's also something wrong because we forgot to mention the starting point, right? The relative part was wrong. Make clean. Okay, it cleans everything. That's perfect, right? So make run. He built and he run. Okay, that's just perfect, isn't it? Okay, so make clean. Now we can start, right?